So if you remember, we have introduced to you biochemical point of health and disease. So I chapter, if you remember, I have told. Can anyone tell me what is in biochemical point of view, how you understand health and disorder? Anyone? We have to just recapitulate. Let me see how good your memory is. See, we are studying biochemistry and you have to study biochemistry, health and disease. You understand? Disorder in point of biochemistry. So that is what is very important. What is biochemistry deals with? What is biochemistry deals with? Everything. क्या हुआ आपके साथ? बताओ. Yes, what is biochemistry? Yes, मेरा लेना. बताओ इस पर ना. What is biochemistry dealing with? Very good. Biomolecules. At least remember that this is a very basis of biochemistry. Biomolecules. We have studied carbohydrates, lipids, proteins, nucleic acid. All these are biomolecules which are being studied in the form of the structural, functional aspect, in the metabolism. So you have studied. So how you understand health in point of this? So if these biomolecules which are present in human body, structurally and functionally involving, if they are present in organized, so 4 words to remember. Remember this 4 words. What are the 4 words? They should be present in organized manner, regulated, to balance and control. So if you see, you have already studied the practicals and in that you have studied glucose. What is it? It is in the range. So what is the fasting range of blood glucose? 70 to 100. So here these biomolecules are regulated, controlled and bring to its controlled range. That is the sign of health. You understand? Every biomolecule which is existing is in this organized manner, mechanism, regulated, controlled and try to balance. And this is the health in point of biochemical point of view. And just opposite is disorder. So if there is, these biomolecules are not organized and they are disorganized, they are dysregulated, they are imbalanced and uncontrolled. If they go haywire from this range, you know, you have just told that 70 to 110, if this is the glucose, if the glucose is now in 200 milligrams, can you call it order of this biomolecule? Then this is leading to a disorder and that disorder is diabetes mellitus, which is characterized by hypoglycemia. You understood? So here you have to understand what is disorder and health in point of biochemistry. Now you have to remember, now what is this disorder due to biomolecules termed as? In anyone? What are these disorders? Which are these biomolecules? Where they are disorganized, where they are dysregulated, imbalanced, uncontrolled. Name that disorders. Or what is that term used for this disorder? So here you remember disorders broadly in 2. One is communicable disorder, the other is non-communicable disorder. Do you know what is the communicable disorder? What is the positive agent or what is the cause of this communicable disorder? Infectious agent, microbes. And the other is non-communicable disorder. Now these non-communicable disorders is nothing but disorder due to this biomolecule, which are imbalanced, which are dysregulated, which are in disorganized mechanism. So here you have to remember, this is the era of non-communicable diseases. How? You will see that currently if you see, this is the WHO statistics, which is showing how much is the world suffering from non-communicable diseases. You can see there is 14 million people dying in each year due to this non-communicable disease. Again, if you see that 71% of all global death, it is NCDs which is being suffered. 15 million people are dying due to, and the age range, now if you see, age of 30, which is a very young age, people are suffering from this NCD. They're suffering and dying. So this is very, very important to understand that these NCDs are rising in their percentage. The death is rising in the toll. And if you see, what are the listed non-communicable disorders? So it is the CVDs, that is cardiovascular diseases, cancer, respiratory diseases, metabolic syndrome, diabetes, malaria. So there is least non-communicable disorder. So among the highest non-communicable, if you remember, the 18 million people are dying with cardiovascular diseases. So there are various multi-etiological factors, risk factors, which is causing this non-communicable disease. And if you see, alcohol drinking, tobacco using, again eating habits, all these are the major risk factors. And this leads to obesity. So the major risk for this non-communicable disease is obesity. So you have to remember obesity, which is caused due to the physical inactivity, which is now very common, overeating, a wrong type of food is ingested. So all these risks and this obesity is later leading to a metabolic syndrome, because we will justify that how this normal adipocyte, which is, what is the lipid which is stored in adipocyte? We have already studied in chemistry part, triacylglycerol. So there is a limit, but if it goes beyond the limit, then this is the condition which occurs, and this is the obesity. So where there will be inflammation, there will be oxidative stress, more free radical generated, and this condition is now metabolic syndrome. And this condition, if you see, the obesity transformed to metabolic syndrome is affecting the whole body, whole system, and every organ. From the top to the bottom, each and every organ is affected due to the biomolecules which are being in disorder, disorganized, unregulated manner, uncontrolled manner. So here you will see all these diseases which are suffering, and they are all this atypical normal. Understanding? So this is what is the main concept. So we will just go through some clinical business before we induce the today's topic. So who will? We want to make this clinical case.
22-year female diabetic patient comes to trauma and emergency department of AIIMS Rishikesh. She gives a 2-day history of vomiting and abdominal pain. She is drowsy and her breathing is deep and rapid. There is distinctive fruity smell from her breath.
Fruity smell. So can you, this diabetic is written, that means it is an NCD, non-communicable, just now we have listed out. So again in diabetes there is a fruity odor which is, can now in this ketoacidosis. Now again, to understand the more basis why this ketone body is in diabetes patient, now again, are you able to explain very clearly now how the ketone bodies are produced in diabetes? It's not clear, and that is why we are going to study to understand more deep biochemical basis of these clinical witness. We have to study the chapter. Now let us go for this clinical witness with this. भाई स्वर्ण इसको ये हटा नहीं सकते क्या इधर? Yes, please.
An old man comes to physician complaining of occasional chest pain that occurs on strenuous activity. He is obese and has a history of hypertension and diabetes mellitus. During physical examination, he admits to eating most of his meals at fast food restaurants. He also reports he has little time for exercise.
Now see, again obesity, again he is diabetes, he is hypertension. So that means this is a case of metabolic syndrome actually. But what is the other condition, or what is the biochemical basis which is making him to suffer, and what are the consequences later which can happen? That all we are going to study in the chapter which we are going to. So again read this. Yes, Alina.
A 27-year-old man with prior medical care was brought to an emergency department because of chest pain followed by sudden collapse. Resuscitation attempts were unsuccessful and caused death. On autopsy, he was found to have thick atherosclerotic plaques in his arteries, including the coronary arteries, aorta, and renal arteries. He also had small, raised, yellow-brown lesions on the extensive surfaces of his arms.
Again here, this is the case of atherosclerosis. You are seeing, aortas are thick and this. So again we have to understand what is this basis, why this atherosclerotic plaque is being developed, all these. So understand the biochemical basis, diagnostic criteria for all these clinical cases, just now what you have read and gone through. So we have to understand the topic, and the topic for today is lipid metabolism. So understanding in health and disease. What is the lipid metabolism in a healthy individual, and if this lipid metabolism is dysregulated, disorganized, imbalanced, uncontrolled, it leads to the disorders of lipid. So this is what is the topic. Now in this topic, what we are going to cover and how we are going to, what will be the objectives of our topic. So first is indication. So very important, how the dietary lipids are ingested, later how it is being digested, absorbed, transported and taken up by the cell. Because actual metabolism takes place within the cell. So we are going to see who are the cells, where these lipids are going to enter and how they are further metabolized. So metabolism is nothing but catabolism and anabolism. That is lipid catabolism means lipid breakdown. So breakdown of lipid is nothing but lipolysis. And lipid synthesis is nothing but lipogenesis. So metabolism of lipid includes lipid breakdown, that is lipolysis, and lipid synthesis, that is lipogenesis. And the transport of lipid. Who are the carriers of lipid? Lipoproteins. So again we are going to study lipoprotein, metabolism, and finally the disorders associated to all these conditions. So this is what is in short the this chapter which is going to be dealt with. So you are going to justify, or during this chapter which we are going to learn, we are going to justify that the lipid metabolism, if deranged, will lead to the non-communicable disorder. This is, and the least stage non-communicable disorder you can understand. And if they are in normal, we can prevent and control and regulate this non-communicable disorder. So this is what is lipid metabolism in health and disease. So what is lipid? You have already studied the chemistry part. Devendra, tell me what is lipid in short. How you tell me? Batao. Lipids are organic or inorganic biomolecule? Organic. Hydrophilic, phobic or hydrophilic? Hydrophilic. Heterogeneous. They are chemically. What are the chemical nature of lipids? Esters of fatty acids. Soluble in organic solvent. Insoluble in water. Because they are hydrophobic. And they are oxidized to produce. What they produce? Produce what? We are the secondary source of energy, that is they produce ATP. We have recently finished carbohydrate metabolism, glucose which is the primary source of energy, and here you remember lipids are secondary source of energy. This to be remembered, and they are utilized by the body and yeah. So this is, you have already studied in the chemistry part in short what are lipids, and here we are going to study justify that how these are going to produce it. What are the mechanisms and pathways which are? So there are 8 human lipids which are associated. Can anyone? Niranjana. Rishabh बताएगा. Engage है. It engaged with the mobile or laptop or both, I don't know. बताओ. Recapitulate the 8 cholesterol. The fast. कितना fast? Cholesterol ester, phospholipid, अपूर्वा बताओ बहुत स्लो है हाँ अपूर्वा 3 बता देने रिमेनिंग 5 से lipoprotein PAG sphingolipid that is glycolipid very good fatty acid और एक glucosamine very good so these are the 8 human lipids which are associated and we have all studied this in our chemistry related to their chemistry and the functional aspect and again in metabolism we are going to understand and know what is lipid metabolism. So in short, if you ask what is metabolism, it is nothing but generation of the biomolecule in the body, then operation of this biomolecule in the body and destruction of this molecule in the body. GOD, generation, operation and destruction of this biomolecule is nothing but in short. If it is the generation of lipid, operation of lipid and destruction of lipid, it is lipid metabolism. If it is of glucose or carbohydrate, carbohydrate. If it is protein, protein. So understanding? So here you have to remember every biomolecule is coming in the body. It is being generated. There is a source. There is synthesis. Understanding? So the source and synthesis should be understood. That is the way by which that biomolecule enters into the body cell. What is the function is nothing but associated metabolic pathway and after the functional use always they have to destruct, catabolize and leave their place and that is nothing but breakdown and degrade. So this in short is nothing but metabolism of lipid. So it is associated with lipid. So today we are going to study association of the generation, operation and destruction with lipid. So, coming to the first aspect, that is ingestion. Ingestion of lipid. So, when we are starting the metabolism of lipid, you have to know what is the way we get lipid into our body. So, ingestion is nothing but eating of dietary lipids. Now, to understand this or make the things more clear, you should know the answers for these questions. Why we are eating dietary lipids? What is the amount, what is the quantity or what is the quality of the lipids which are to be ingested and in what form we have to ingest. What are the sources which are being present and we have to choose and ingest this lipid. So this is going to complete our ingestion part. Now first question to answer, why do we eat dietary lipid? What is the importance of eating dietary lipid? बिना मकसद के कोई जिंदगी है क्या? Is there any life without aim and objective? No. See all your here sitting is some aim and objective. निश्चित बोलो. Why you are sitting here today? कि भैया learn के बाद फिर मैं एग्जाम अच्छे दे दूँगा. I will get good marks. Maybe I will get award during that. ये भी aim है, objective है. हो सकता है फिर डिग्री मिले आगे, डिग्री के बाद नौकरी मिले, नौकरी के बाद छोकरी मिले, ये ऑब्जेक्टिव इसीलिए तुम लोग भाई जितना अच्छा पढ़ोगा उतनी अच्छी डिग्री, उतनी अच्छी डिग्री, उतनी अच्छी नौकरी, उतनी अच्छी छोकरी, ये ऑब्जेक्टिव. So here in our body anything we are doing is not without any aim. So we are eating, we should eat, or if we are eating, why we are eating? Anyone? बताओ लिखिएगा. बिना सोचे समझे खाए जा रहे हैं या आज हम समझे क्यों खा रहे हैं. अगर खाने हैं तो क्या फायदा. आज खा रहे हैं लिपिड जा रहे हैं तो ये क्या है.
बॉडी फंक्शंस होते हैं उसकी हमारी बॉडी में. जैसे मैं हीट जो होता है उसका इंसुलेट होता है और
anyone लवचिका तुम कुछ खा रहे हो बताओ मुंह में तुम्हारा चल रहा है. वाइट के पास हमारा टाइम कम है. एनीवन क्रैकर नहीं बताओ करोगे? चलो. Why to eat lipid? अभी तो बोल रहे थे. We eat. It is a predominant lipid eaten. Can anyone? Triacylglycerol. What is triacylglycerol? 3 fatty acids linked to. That is, it is the store form of fatty acid. You all know. So 98% of the lipid ingested is PAT. So why we eat PAT? So after PAT in the ingestion, the fatty acid is going to be released, and these fatty acids are going to be oxidized and produce ATP. So we are eating lipid because first of all they are the macronutrients of the food substance, and very important is they are the source of energy, secondary source of energy. Secondly, the PAT which is having fatty acids, they have PUFA, SPAS, PUFA. Now what are PUFAs? Polyunsaturated. Our body is producing this PUFA. Is SPAS produced by the body? Yes. Saturated fatty acid can be produced. Folic acid, PUFA, can it be produced by the body? Yes. Can PUFA be produced? No. So we should eat the PUFA and lipid to get this. Because these are not. So here very important thing, why we eat lipid to get the PUFA. This is again. Now these PUFAs are next. Recently we have finished vitamin or fat soluble vitamin E, K. Imagine these fat soluble vitamins are associated with fatty or lipid diet. If we eat a lipid diet, we are getting this all fat soluble. Is it not good? Is it not important? And we have all seen how important are all these vitamins which are playing important role. Ghee dosa, sada dosa. Which is more tasty? Option there, do dosa. Ghee wali or एक शादी. You all. So ghee, all this butter, tarta, all add this. Taste to the recipe. Next is palatability and satiety value. If you eat more lipid, so you will be more full with less amount because it increases your satisfaction of eating. So palatability and satiety value is again improved and increased by eating or ingesting this dietary lipid. So one more, again I have put this slide. So if you are asked why to eat lipid, to get PUFAs, to get that fatty acids which are not being synthesized in our body. So if you see, there are 3 PUFAs. Can enumerate? Can anyone? What are the omega 3, omega 6 fatty acids? Nipunatri, batao. Name the PUFAs. Name Vaibhavi. बताओ PUFAs क्या हो गया? You are the ranker. बताओ जो PUFA के नाम बताओ. कौन बताएगा? रेन एंड फटाफट. It is linolenic, linolenic, arachidonic, docosahexaene, phenolic, timnodonic, carbonic, nervonic, बहुत सारे हैं. समझ में आ रहा? जाके पढ़ोगे ना पता. And these are all structurally important because they are the components of the biochemistry. They are important in the brain and health of heart. The growth, development, functioning of heart and brain is dependent on this PUFAs which are. So these are the very important PUFAs which are. Have you heard about eicosanoids? Derived from which fatty acid? And what is arachidonic acid? It is a 20-carbon PUFA. So these PUFAs which are omega 3, omega 6, they have very important role in heart. So it is noted that the individuals who are eating PUFAs, they are protected from this cardiovascular diseases because these PUFAs have anti-hypertensive, anti-inflammatory, anti-androgenic and anti-thrombotic. That is, it prevent the thrombocyte to clot, aggregate. So there is no risk of developing clot, atherosclerosis, No. So the blood pressure will be regulated. All these are the good effects because the biomembranes which are containing this PUFA, they are in more elastic and more and less damaging. You understanding? Unless until again antioxidant should be again abundant and proper. So if the ingested lipids are less of PUFA, so what is suffered? What is the disease we have already studied? There is phrenoderma, toad skin. This is deficiency where there is the skin becomes scaly. There is protrusion of the hair. So if you see here, see this is the toad skin disease phrenoderma, and this is caused due to the deficiency of PUFA. So again the heart, the brain, it is to be developed, they will not be developed as required. So understanding? So in short, at the end, what is the significance of eating? Why we are eating? To protect our heart, brain, to have a normal health, growth, normal reproduction, because this is very important for every human life. So this is maintained normal because of the daily consumption of the fat. Now the next question, what quantity to be eaten? What quality to be eaten? Quantity is nothing but the recommended dietary allowance. So again it is noted that 20 to 35% of lipids are coming in a day. Suppose 2000 is the calorie per day requirement. So 20 to 35% is to be come from lipid. That is what I mean. Now, but again you have to remember the ingestion of lipid is based on this factor, habit and economical status. And you know that economy because if you want to buy ghee, it is very costly. Fish, costly. Go and buy, it is very costly. So, based on your economy, the food, and then what type of oil? Olive oil, which is rich in PUFA, very high costly. Palm oil, less. So again, the type of lipid which is ingested are based on this. So remember, 20 to 35% of dietary lipids are providing the calories. So 700 calories are coming from out of 2000 calories. Now, what is the RDA? You can remember 20 to 50 gram per day. You have to remember. कितने gram खाने हैं? In an adult individual, 20 to 50 grams of dietary lipid to be ingested. And again, you know, just now it is very clear why we are eating lipids. Then PUFA. And again, which PUFA? Omega 3 and omega 6. So see the percentage. You have to have omega 6 with 6 to 8%, omega 3 with 1 to 2%. So this should be our RDA or the quantity. Now the quality, what? So already you know what quality. So you should know that we are eating triacylglycerol, but the triacylglycerol, it is being eaten 98% predominant. We should have association of PUFA. This is very important. You have to select that CAGs which are linked with PUFA. That is what is very important. The other lipids which are ingested are phospholipid, cholesterol ester, and fat soluble vitamins which are present. Now, quality which PUFA should be eaten? Natural, cis, trans, this form. So again you have to remember the lipids should be natural, they should be of PUFA, that is omega 3, omega 6, which should be of cis form, and generally an ideal ratio of PUFA, MUFA and S5 should be maintained so that we get all these fatty acids and help in our composition, structural and functional aspects. Should we avoid trans fat? Yes. We should avoid because they are not metabolizable, and if eaten, they will remain in our body cells, in the artery, and increases the risk of atherosclerosis. So we have to remember, we should choose the lipid which is of natural, not processed. the hydrogenated. So trans fatty acids or trans fat are hydrogenated. These are processed fats. Dalda, vanaspati, ये जो है, so all the junk food, biscuit, all they contain this rich source of this fat. So that is what we have to remember. What to select and what to eat. So let's know what to select. Now we know it should be natural. So let's select the natural. So you can select the various forms of lipid present in both plant and animal, and it is in the plant in the form of oil, nuts, and in animal you already know the animal sources always provide the good triglycerol which the pupa contains. So again there are two forms of fat, visible, it is visible like ghee. दिख रहा है ना, oil दिख रहा है, so these are visible, and non-visible or invisible means it is mixed egg yolk as phospholipid, but it is not much very clear to your visual. So such fats are called invisible fat, which are present in nuts, seeds, and milk. Now we know that pupa are to be taken. So the pupa rich oil is olive oil. So again you have to remember, olive are rich in pupa containing, and pupa containing all the nuts are rich in pupa. So again if you see, these are the foods which are rich in omega-3, that is alpha linolenic acid and high in omega-6. These are the food substances which are present. Now again you can see the chart. See this chart, which is highest in omega-6? Cat flour. And which is rich in omega-3? So you can prepare fish fry or fish curry with safflower oil. That means omega-3 or omega-6. Simple है ना? भैया हमें omega-6 भी चाहिए, omega-3. अब ये चूज कर लो, ये चूज कर लो, ये इससे बनाओ करी और ये मिल गए दोनों. So like that way you can see that which, because we need both omega-6 भी omega-3 also. So flaxseed पता है? अलसी, in Hindi it is अलसी. So see again flaxseed is rich in omega-3. That if fish नहीं खाने वाला उतना तो खाए 50%. Something is passed over that 100% ranking नहीं, 50% flaxseed. So choose this. Again corn, sunflower. So you can choose those who are not eating fish and this. So खाने something is better than nothing. So please, these are the things which you have to understand. Again, extremely high. अगले चार्ट में यहाँ नहीं पढ़ पाऊंगी. I will be submitting the notes. You can read, choose as per your choice, as per your taste, as per your economy, and try to indulge in your ingestion. So omega-3, omega-6, very important. Why I am revising it? Because these are the pufas which are entering into the body and forming the eicosanoids. Again, remember the eicosanoids, which are again very important in the immune mechanisms. They are important, and that is why if these pufas are deficient, their body will be having deficiency of these eicosanoids, prostaglandin, leukotriene, thromboxane, resolvin, protectin. All these substances are derived from the pupa. And that is again we have to see for this is the precursor and has to be ingested. And already I told, to have a healthy heart, healthy brain, we should ingest the pupa which are glucosaminoic acids, DHA, very important. Nervonic, survonic, all these are the fatty acids which are pupa which are helping in the brain health, and that is what you have to remember. And so this is the part of ingestion which is very important or no? But no book has given this part. जाके पढ़ने. Biochemistry की एक भी book नहीं है कि जो ये ingestion part cover कर रही है metabolism of lipid में. But this is very important. Ingestion होगा तो ही digestion होगा ना. Just not directly from digestion. You should know which form is ingested, in what form it is being ingested, So now you are clear which forms are ingested? Triacylglycerol, phospholipid, cholesterol, ester. And what is digestion? What is the process of digestion? To break the complex unabsorbable moieties into simpler absorbable moieties. So lipid digestion is going to occur in the various parts of the GI, starting right from the mouth. So here if you see what will be the digestion, so you know lipids are having this bond, ester linkage. You know in carbohydrate this bond, glycoside. In protein, peptide. So protein digestion was breaking the peptide bond. Carbohydrate digestion is breaking that glycoside, and lipid digestion is breaking the ester bond. So simple. So we are eaten that lipid form which has the complex link with the ester linkages. So which are complex and unabsorbable, but by the lipolytic enzymes which are present in the GIT, these enzymes are termed as lipases. What is that? There is a proteases, glycosidases. Now these are lipases. So lipases are the enzymes which are going to break these complex forms of lipid which are being ingested and now in the GIT, and they have to make into a simpler form which are absorbable form. So this is what is digestion. Now what is the prerequisite before breaking this PAG, before breaking this phospholipid, before breaking this cholesterol ester? What is the prerequisite? क्या requirement है? So here you have to remember the health of the GIT. The GIT health should be good, healthy GIT, healthy stomach, healthy intestine, so that there is a secretion of the various GIT hormones which regulate the secretion of the gastric juice, intestinal juice, bile. All these are to be secreted, which are essential for the lipid digestion. Various enzymes, just now I said lipid digesting enzymes, they are again prerequisite. They are going to act and break that ester linkages. The pH for this reaction should be again optimal. That pH should be present where these enzymes will act. And very additionally, which you haven't studied in carbohydrate and protein digestion, is the emulsifier and emulsification. Other lipid digestion, absorption, and if you forget these 2 points, who is this sleeping? Nipunatri, कौन है बगल में तुम्हारे? विनी, चित्रपति ये कौन है? ये तो सोरी के सरगस के बगल में आदित्य, कौन है? Sit straight, sit straight. हाँ. जो सोरे उनको मार्क एब्सेंट, समझ में आ रही है? रोज एंड रिमूव दिस बैग, ये जो आसरा लगा के सोते रहते हैं ना, इस बैग को हटा दो, रिमूव, उसको सुला दो, तुम उठ जाओ, बैग को सुला दो, ठीक है? Let the bag sleep and you be awake. So emulsifiers and emulsification very important. अगर ये आप भूल गए तो यू हैव जैसे मतलब सो गए लेक्चर, यही समझ में आएगा कि अगर आप emulsifier और emulsification नहीं बोला in the lipid digestion, that means you have not understood. You will be asked what is the very uniqueness of lipid digestion and absorption. What is the prerequisite? Emulsifier, presence of occurring of emulsification process, 100%. Okay. Activeness is 100%. So here the GIT hormones, which are very important, and they are helping in the digestion. So let us understand. So the hormone gastrin. So this gastrin, which is secreting by the gastric mucosa, it is helping the secretion of HCl by the parietal gland. It is helping the mucosa of the gastric to form, and again it produces the gastric motility, and acid chyme is going to be produced, and these acid chyme later then stimulate the next 2 hormones, that is CCK cholecystokinin and secretin. Now this CCK क्या करता है? It will make the gallbladder to secrete and release the bile, which is stored. Then this secretin, which is there, it is stimulating the pancreas to release the pancreatic juice. ये pancreas को अब खाना आ गया है, लिपिड आ रहे हैं, हाँ, स्टमक में, चलो चलो चलो. Message, who are these? Hormones. Hormones are the messengers, and they are the regulators of enzymes. So, पहले awaken things. So they try to, and then if suppose sufficient stomach has been filled, now to regulate, there is enteroprogesterone, which inhibit the gastric motility. So regulate भी करना ना, continue the on भी नहीं रखना है, continue the off भी नहीं रखना है. So the hormones are there, some stimulate, some inhibit. So like that way, these are the main hormones which are regulating in the secretion of the juices, enzymes, and now coming in the DIT, where already the lipid come into experiment. ऐसे नहीं कि जब lipid नहीं है तो ये नहीं होता है. When there is empty stomach, they are not stimulated. But when there is lipid in the DIT, these hormones are stimulated and they come into the this. So here enteroprogesterone, just now I said, it is stopping the gastric motility. So what will happen? If there is no motility, the food acid can is not going to move into the intestine. So there will be stomach which is being full with it. So this will make the increasing the satiety value. So this is how you have to remember that hormone also regulates, and the food which is still in the stomach will keep within, and if the stomach is full, so it will give a message to the hunger center that stop eating. I am already full. यहाँ खाली होने दो, फिर तुम आना, है ना? So again that message goes. So after the hormone knowledge which are associated with lipid metabolism, you should know various lipases which are required for digesting this lipid. Now in the mouth there is a lingual lipase. In the stomach there is a gastric lipase. In the pancreatic juice which is pouring in the intestine, there is the pancreatic lipase. There is intestinal lipase. So these are the four different lipases present in the DIT which are going to cleave which bond? Ester. So we are going to see how these various lipases are acting and trying to break or bring the lipid digestion in the different parts of the DIT. Now lingual lipase and gastric lipase. If you see, I have already told lingual lipase, this is secreted by the von Eberner's gland, which is below the surface of the tongue, and they require, and gastric lipase, which is there, it is produced from the stomach, and they are acting on the DIT. Now very important is, these lipases are not having a very good activity in the mouth and the stomach. They have very low activity. They act on the triacylglycerol, which are having short and medium chain fatty acid chain. If the PAG is with long and long chain, this lingual or gastric lipase are not going to act on it. This is again the thing you have to remember. So the milk, what is the predominant diet of neonates? Milk. So in milk, this gastric lipase, lingual lipase is significant in action. But in adults, this is not much insignificant. The reasons we are going to understand why it is. So this lingual and gastric in neonates, and in pancreatic disorder like cystic fibrosis, where the pancreatic lipase is not there, something is better than gastric action. So then it is noted where the pancreatic lipase is absent. So at that time these lipases work to their max, otherwise not. So with long chain it is very minimal. It is very insignificant. That's what you have to remember with lingual and gastric lipase. Now, why they are not so good in action? The reason is in mouth, in stomach, there is no emulsion. What is the thing you are doing? In mouth and in stomach, there is a prerequisite. हमने पढ़ा था prerequisite क्या? Emulsifier, prerequisite क्या? Emulsification process. So this process is not taking place in the mouth and stomach. So there is no emulsifier, no emulsification, and that is why the action of these enzymes is insignificant. Again, the activity is low because there is no optimal pH which is being required by the enzyme lysis. So understanding? So that is why there is no cleavage of ester bond by this gastric and lingual lipids. Now, just now we understood what was the digestion status in the mouth and in the stomach. Now, it was insignificant, it was incomplete. Now, where is it going to have a complete and significant digestion of lipid? So, what is the answer? It is in the small intestine. Significant digestion of lipids going to be taking place, which are being ingested in the small intestine, and the reason will be the same. There will be optimum pH, there will be emulsifier, and there will be emulsification process which is going to be present in the intestine, and there will be peristaltic movement which is being. So here you have to remember PAG is the major lipid which is being ingested. So they will be going to be digested. So the surface area has to be improved and increased, and this is requiring the emulsifier. So let us answer 3 questions, 4 questions. What are emulsifiers? Who are the emulsifying agents? What is emulsification? Where is this emulsification bringing out? And why emulsification is, or how emulsification is significant. So let us answer this question. So who are the emulsifiers? Can anyone say? Yes. Huh? Who are the emulsifying agents? This is the question. Bile, salt. Present in bile. Understood? Obtained from bile acid. Here. So here you have to remember the lipid digestion is requiring the presence of bile in the intestine, in the small intestine. So what is bile? It is a greenish fluid which is produced in the liver, again stored in the gallbladder, concentrated there, and then it is carried through the bile duct and common bile duct and coming into the small intestine. And just now you know which are the hormones? TCK. Cholecystokinin is going to contract the gallbladder to release the bile in the small intestine. So bile, if you see, it is composed and it is alkaline. It has the surfactant, that is bile salt. It has a pigment which is called as bile pigment, nothing but bilirubin. It has bile acid, cholesterol and phospholipid lecithin. Let's see the composition. So if you see, this is the composition of bile present in liver and gallbladder. Compare it. Which is concentrated one? See, the gallbladder is concentrating, and if you see the bile salt concentration or quantity is increasing, and if you see in the bile, which is the major component? So bile is having maximum amount of bile salt, and these are the additional things present in the bile. There are iron, there is sodium, potassium, calcium, chloride, bicarbonate, the phospholipid, fatty acids, bilirubin, which is the bile pigment, cholesterol, bile salt. All these are the components of bile. Where it is concentrated? Gallbladder. Very good. So if you see, this cholesterol is the precursor for bile acids. And who are the primary bile acids? Remember this name? Folic acid and chenodeoxycholic acid. These are said to be primary bile acids. On these bacterial enzymes act and they convert into secondary bile acid. And who are the secondary bile acids? Deoxycholic acid and नहीं है वहाँ लोग पहले कमेंट सेकंड पर मैं प्राइमरी पूछा था सेकेंडरी पूछा था प्राइमरी choline and spinodeoxy methocholine and deoxycholine these are secondary and these bile acids in alkaline medium and linked with glycine or taurine becomes glycocholic tauric acid and their salt that is glycocolate that is sodium glycocolate and sodium taurocholate. So these are salts of these folic acid अभी बोला क्या है प्राइमरी है sodium glycocolate sodium taurocholate. If you see these conjugates, so 3:1 मतलब glycocolate or sodium glycocolate is major 3:1 that is sodium taurocholate is lesser as compared to the sodium glycocolate. So this is again you have to remember these are the bile salts and these are emulsifying agents and they are going to form emulsion. What are they going to do? Emulsion. Now what are emulsion? So emulsions are nothing but they are the suppose you take a glass of water. To this you add 1 teaspoon of oil. So you will see large droplets which are on the surface of this water. So this large droplet. Now to this you add some detergent and take a spoon and try to mix it. And this you take in a glass कांच वाला. That in that water is taken and this all things are being done. Now what you see earlier the large droplets which were there. Now because of acting of this detergent and shaking and mixing, you will see that now that large droplets have been broken into smaller droplets and they are mixed in the cold water of that glass and these small miscible droplets are called as emulsion. What are emulsion? This is a dispersion of the large droplets of oil and this dispersed and made it into a miscible form is called as emulsion. So here in the glass कौन कर रहा है? Who is doing the detergent action? That is detergent. And the same glass को consider करो intestine. वो detergent का action है bile salts और चम्मच का काम है peristaltic movement. So the antipathic lipids and bile salts are acting as a emulsifier. Antipathic lipids also. You understanding? So these antipathic lipids and bile salts, they are acting as a detergent-like action, which are going to increase the surface area of that oil and reduces the surface and making that fat or oil droplet into a miscible form. Now, where are enzymes present? Can anyone say? Where are enzymes present? Enzymes are polar or non-polar? Polar. So they are inside that water. And earlier there was the oil droplet up for oil नीचे enzyme क्या होगा? मिलन होगा क्या? No दोस्ती नहीं, दोस्ती की तो आगे कैसे बढ़ेगी? ऐसे अगर तो action of enzyme, breaking of enzyme not possible, but emulsification is doing there. वो जो particulate, वो जो large droplet अंदर घुसो, ठीक है? Come closer to that enzyme. Now interact, communicate, bind, leave that bond. So is emulsification facilitating the process of digestion? Yes. It is making the non-polar lipid and making it into bringing in contact with the soluble polar form, and that is this whole process is called as emulsification, which is initiating and completing in the small intestine with the help of emulsifying agents, which are bile salt, sodium glycocolate, sodium taurocholate. Revise. कौन है bile salt? Sodium glycocolate, sodium taurocholate. These are the bile salts which are helping, and these is required before digestion. Before digestion होना है, तभी digestion हो पाएगा. इसीलिए, and where it is in the intestinal lumen. See, a large droplet of oil broken and dispersed. ये क्या है ये? What is this now? ये क्या है? Emulsion. मेरे को देखो पहले बेंच आते कैसे एक्टिवेट और कैसे आंसर, हाँ कल से तो मैं यहीं बैठो तो इमल्शन बनेंगे एंड इमल्शन देखा पहले मैंने बोला ग्लास ऊपर फेज भी दूर दूर ना ना लड़ाई ना झगड़े ना प्यार ना मोहब्बत पर देखो बात याद रहेगा। इन्वेस्टिगेशन आर वेरी इंपॉर्टेंट टू रिमेम्बर। फिर बोला हो रही कि नहीं टुकड़े टुकड़े। So dispersion of blood droplet, miscible and emulsion. See, if you see what is this green part, these are all byproducts. They are making. देखो कितने छोटे छोटे form बना रहे। These are miscible and they are now presenting to the enzyme. See, this is a large fat droplet. उसका थोड़ा टुकड़ा तोड़ा और present किया enzyme। See, each figure is helping you to better understand, है ना? So see how this is oil. उसमें का थोड़ा bind here, bile salt. Who is bile salt here? This is the this green is the bile salt and this is the enzyme which is presented. See, this is how emulsification is occurring. This again you can see this is nothing but the triacylglycerol which is to be digested and it is presented and brought. So amphipathic lipid, bile salt, these are forming emulsion and who are achieving peristaltic, bile salt or phospholipid, all they are facilitating in the emulsification and forming the emulsion and this bringing the enzymes closer and now these enzymes are ready for action on that ester linkages which are present. So if you are asked what is the significance of emulsification, these are the points you have to remember. How emulsification is significant because first it has to form emulsion. These emulsions will reduce the surface linkage, increases the surface area of that lipid, improves the visibility, bring contact with the enzymes and the enzymes are then going to act and cleavage and the digestion, making it simpler form. So just imagine if there is no emulsification, do you think of occurring of this digestion? That is what you have to emphasize and remember how important it is. So we saw bile salts are present in bile and brought into the intestine to bring this emulsification. एक बार काम हुआ फेंक दिया बॉडी इकोनॉमी सी द इकोनॉमी ऑफ द बॉडी और काम करने की क्षमता है, चलो इसको फिर से यूज करो, रीयूज करो till it works. So 95% of bile salts are recycled and reutilized, and to reutilize they are reabsorbed from the intestine. Brought कहाँ बन रहा है bile? Where is bile synthesized? Again liver को पहुंचा है, so that it mixes with the fresh bile and then again they secreted intestine. So only 5% are wasted and excreted through the feces or stool. 95% see the economy. एक बार fat use it till the best use, till the maximum use, and it is the message given by our body's mechanism. So let us understand and this. So enterohepatic circulation is nothing but the circulation from the intestine to this how. So today we have introduced to lipid metabolism. We saw how the lipids are ingested and what are the prerequisites of the digestion. It is very important is the role of emulsifier, the bile salt, sodium glycocholate, sodium taurochelates, bringing the emulsification significantly, initiating and completing the lipid digestion in small intestine. So again it is not complete. So tomorrow our next part will be how these various